Welcome to qnawire.
Hi, so over here we're going to have the bromination of cis stilbene, which is going to be labeled. I'm going to abbreviate the benzene rings just with the following formulas. So this is going to be the compound that we're going to consider. Just for sake of simplicity of the reaction mechanism, I'm going to replace the benzene rings with a phenyl, and this is going to be the reaction that we're going to be looking at. So remember that the reaction of bromination is going to have an anti-addition, and that this is going to generate a racemic mixture. So the reaction mechanism is going to be as follows. First of all, let's write down, let me erase this line over here, our bromine as Br. So first of all, this reaction mechanism is going to go through something that is called a bromonium ion. So let me just write down all of the charges over here. And what is going to occur on the reaction mechanism is that a pair of electrons goes towards the bromine. The same pair of electrons goes, another pair of electrons from the bromine goes into the double bond, and at the same time a pair of electrons goes into the Br on the other side. This is going to generate the following compound. We're going to have our two phenyl groups. The double bond is going to be lost to favor the Br species that we're going to have over here with our phenyl over here. So this is going to have a Br with a positive charge here, and we are also going to generate Br minus as an spectating ion. In this case, the correct stereochemistry is going to be to have essentially this bromine both looking towards the top of the ring. And the next step of the reaction mechanism is going to be the anti-addition of this bromine group. So the bromine, I'm going to draw it down below just for sake of simplicity. Now is going to attack either of the carbon atoms and take away the pair of electrons towards the bromine. So this is going to generate our final product, which is going to be, keeping the correct stereochemistry, we're going to have our phenyl group over here. Well, actually, let's do it like this. So we're going to have on this side our phenyl group. The phenyl group is also going to stay the same over here. But what is going to change is that on one, the bromine goes into the back, and over here it's going to stay on to the front position. Another way to write down this compound would be to have the bromine over here. I'm just giving you an extra option because depending on what are your visual cues, sometimes it's easier to look for one or the other. And in this case, both phenyls would go over here. And under this condition, the enantiomer that would be generated would be also the one that we are going to show here. Bromine and bromine, they need to be on opposite sides since they are going to be added to in an anti-fashion, and our phenyl groups over here. Phenyl, and this phenyl also is going to stay over here. And now, just to determine the order of priority, remember that according to the Canningle-Prescott rules, we are going to look at the atomic number directly. So for that reason, whenever we have a chain, what we need to identify is what is going to be the next thing. So for example, In this case, the phenyl, we're going to have first a carbon atom, then double bonds, another carbon atom. So for that reason, this is going to have a lower priority than this carbon attached to a bromine atom. So the order of priority on each of the substituents is going to be the following: 1, 2, 3. Well, let me put the two a little bit closer just to exemplify over here. 1, 2, and 3. So we're going on this direction. That means that we have an absolute configuration corresponding to an R configuration. And on this side, the order of priority is going to be 1, next up 2, and next up 3. So over here, we would have a counterclockwise generating an S configuration. Now, on the other side, we're going to have a configuration coming for, in this case, it would be 1, next up 2, and 3. So, counterclockwise, this would be an S configuration. And over here, we're going to have... Actually, sorry about that. I think I made a mistake over here while drawing these structures. So let's discard them over here. Let's stick with the original one that I had over here. So in this case, the correct configuration would be the priorities 1, 2, and 3 as follows. This corresponds to an R, but since the bromine is looking onto the back, this would be an S configuration. On the other hand, the priority is going to be 1, 2, and 3. So over here directly, we're going to have the configuration as follows. So this would be an SS configuration, and we're going to have the racemic mixture corresponding to the RR configuration, in which we're going to have now the exchange of these bromine atoms, bromine with the phenyl group. Now let's draw the bromine looking into the back, and our phenyl group over here, just to keep everything nice and tidy. And this would be the RR stereoisomer corresponding for this reaction. So with that, it would be all. Thank you very much, and have a good one.